Hello, my name is Mr. Wyrick, and I'm here to talk to you about lesson 4.7, which is the 7th lesson from chapter 4, which is about congruence transformations. When we're talking about this kind of stuff, there are quite a few definitions on the first couple pages here of the chapter, or the first couple pages of the lesson. So 296, 297, make sure you look those over, make sure you get those down in your notes, make sure you get them defined, and then we'll talk a little bit about what they are. Anytime we have a transformation, we always go from a pre-image to an image. Typically, they'll take the one that happens first, and if we're still talking about triangles, it'll be a triangle labeled A, B, C. So then whatever it's changed to, and again, I'll go over this down here kind of, but whatever it's changed to, when we move it, it goes to A prime, B prime, and C prime. And then if it's changed another one from there, B double prime, A double prime, C double prime, we just put a couple of basically quotation marks, apostrophes to indicate that a change has happened and in what order that change happened. The ones that we're talking about specifically are congruence transformations. So you're not going to see changes in size here, or you shouldn't. And this is, I believe it's pronounced isometry or isometry. If you've been taking your Latin roots quizzes in Miss Payne's class or Miss Kiefer's class, iso means same, and metry would be meter, would be measure. So we understand that the measures of the sides are going to be the same if we are doing stuff like that. The first one is reflection. So when we have reflection, we have an imaginary line. It could run up and down, it could run across, so it could be vertical, it could be horizontal, it could even be on the angle. And when you get into Algebra 2, you'll have some of these that are on the angle. But we have some kind of shape. I'll do a triangle here. And when we reflect that, it has changed direction. So we've got a reflection here. When we've got a translation is a slide. Okay? You can think of the reflection as a flip. It's going to flip what we're working with. A translation is going to slide it. So if we have this triangle up here, we take all of these and we move them the exact same distance, and then we have our shape. I suppose that should be more direct. We have our shape down here. We just take where it is and we slide it down to somewhere else. And then a rotation or a turn or twist. The rotation's a little more difficult to pinpoint sometimes, but we'll take something like this point here, and if we had a triangle that looked like this, we would take it and rotate it so that it would look like this. The rotation is going to be the one that causes the most trouble with how we're doing this. The translation, the slide, is usually fairly easy to figure out. You can kind of count and move over. The reflection, you can find your distance to your line that you're reflecting and then just go that same distance on the other side and figure out if it's an accurate reflection, if it's an accurate translation. The rotation, you really need to know that point, and you have to think about how you need to change the values for what you're dealing with. The points typically go from like an x comma y to the new point being something like y comma x, and depending on where you are, it can make them positive, it can make them negative, it can really kind of change how things look. If it's just asking you to classify them, it's a little simpler. But they're going to ask you to prove that you know that it's still congruent afterwards. These are all going to be on Cartesian coordinates. It's all going to be on a grid, unless they're just asking you to quickly identify what kind of change was made. So you'll see it on the grid. And they do that so that you can calculate the distance, so you can make sure the sides are still that same distance. It'll be okay on this to not have to calculate decimals in that way. It'll be probably easier to just leave it in radical form and say, okay, this one's square root of 34, and the new one is square root of 34. It's still the same, so it's still congruent. There's probably going to be more of these transformations, and we'll probably deal with some dilations within the next few lessons. But even if we don't, remember, these are specifically the types of transformations that will keep it exactly the same measurements. So we've got a reflection or flip, a translation or a slide, and a rotation or a turn. That's what we will be dealing with in this lesson.